Hello everyone, today we're going to be studying atomic structure from Edexcel AS level chemistry unit 1. Let's begin. So the basic idea is you have to memorize this definition of atoms. Atoms are the smallest parts of an element that can take place in a chemical reaction. Protons, neutrons and electrons are known as subatomic particles. That is what atoms are made of. Inside the nucleus we have protons and neutrons, and protons are positive, neutrons are neutral, and electrons are negative. Electrons are surrounding the nucleus in the electron cloud. So this is relative mass and relative charge of the subatomic particles. Relative mass of protons is 1, neutrons is 1. Electrons are extremely small and light, so their weight is 1 by 1840. The accurate is 1 divided by 1836, but in our specification we have 1 by 1840. Relative charge. Protons have a positive 1 charge. Neutrons are neutral, so they don't have any charge, 0. Electrons have a negative 1 charge. Atomic mass and atomic number. Atomic number is the proton number. This is what defines an atom. Proton number means the number of protons present in the nucleus of an atom. Atomic mass or mass number. Mass number is the amount of nucleons, that means protons and neutrons present in the nucleus. Number of neutrons is equals to mass number subtract atomic number. Like over here we have the example of oxygen. The atomic number is 8, which means there are 8 protons, and the mass is 16. So if we want to calculate the number of neutrons, we need to subtract 8 from 16, which is 8. So 8 neutrons and 8 protons. Some basic concepts. Atoms are neutral, that means they have no overall charge, because number of protons is the same as number of electrons, so charges cancel out. We have same number of positive charges as well as same number of negative charges, so the charges cancel out and leave us with neutral atoms which have no charge. But ions are atoms that lose or gain electrons, okay, so they can have charge. If an ion loses electron, it can gain a positive charge, which means there are more protons than there are electrons, which gives the atom a positive charge, which is also called a cation. Likewise, for an atom who gains an electron, for that we will have more electrons than there are protons, which means there will be a negative charge, which results in anions. Ions that have same number of electrons are isoelectronic. We have some examples. Over here we have fluorine. So the mass number is 19 and the atomic number is 9, which means number of protons is 9. For neutrons we have to subtract the proton number by the mass number. 19 minus 9 gives us 10. So there are 10 neutrons, and number of protons is the same as number of electrons, so 9 electrons and 9 protons. And to distribute 9 electrons, as we have covered this in the IGCSEs, so there would be 2 in first shell and then 7 in the second shell. So if we turn it into an ion to complete the octet, so same number of protons because it is the same element, 9 protons, 10 neutrons, and electrons would be 10. So now the distribution would be 2 in the first shell and 8 in the second shell. Elements, compounds and mixtures. Element is a substance made up of only one kind of atom. Compound is a substance made from 2 or more different elements that have been chemically joined. Mixtures consist of 2 or more different substances not chemically joined together, and they can also be separated from physical methods. As you can see on the side, I have some examples: atoms and molecules of the same atom, so these are elements. Compounds have 2 different types of atom and they are chemically bonded, so that is a compound. And in mixture we have atoms, we have some molecules, and we have some compounds which are not bonded, so this is a mixture which can be separated. Isotopes. Isotopes are atoms of the same elements, which means they have same number of protons but different number of neutrons. And since atoms react by either giving or taking an electron, the chemical properties of the isotopes are similar due to no change in number of electrons. However, the physical properties are different because addition or subtraction of neutrons result in addition or subtraction of atomic mass. Basic idea: isotopes are atoms with same protons but different number of neutrons. Again, electrons remain the same, so there is no change in chemical reactivity, but there are difference in physical properties because we have added or subtracted mass. As you can see on the side, I have example of carbon 12, carbon 13, and carbon 14. In the first carbon 12, we have 6 protons and 6 neutrons, which means mass number is 12. The second, we have 6 protons and 7 neutrons, which is mass number 13. And in carbon 14, we have 6 protons and 8 neutrons, mass being 14. Electronic configuration. Electronic configuration shows the arrangement of electrons in an atom's energy levels, sublevels, and orbitals. It follows the rules based on quantum mechanics principles. So we have 3 principles: Aufbau principle, which says electrons fill orbitals starting with the lowest energy level. Then Pauli exclusion principle. Pauli exclusion says each orbital can hold a maximum of 2 electrons with opposite spins. And Hund's rule, electrons occupy orbitals of the same energy singly before pairing up to minimize repulsion. I'll be explaining these further. So if you look at the table, we have energy level, which means the shell, the first shell, the second shell, third shell, fourth shell. Sublevels in main energy level, which means the sublevel that are in the shells. So in first energy level, which is the first shell, the subshell is S. We have 4 types of shells: S, P, D, and F. They all have their own orbitals and we'll go through them. Okay, so in the first shell, we have the S subshell. And in S subshell, we have only 1 orbital, and in each orbital, we have 2 electrons. So that's why in the first shell, only 2 electrons can fill up. In the second shell, we have S and P. The S has only 1 orbital, but the P has 3 orbitals. And since 1 orbital can hold 2 electrons, 3 orbitals can hold 6. So when we add S orbital and P orbital, they all result in 8 electrons being held in the second shell of an atom. Move on to third. There are 3 subshells: S, P, and D. S has 1 orbital, P has 3 orbitals, and D has 5. When we add the electrons, there are 18. That's why in the third shell of in any atom, we have 18 electrons, and so on. So each sublevel is made up of orbitals. Orbitals are regions in an atom that can hold 2 electrons with opposite spins. This is also a definition that you need to remember. On the side, as you can see, there's a picture with arrows. This is the way from lower energy shells to higher energy shells that we fill up. Like if you follow the arrow, there is 1s2, then there is 2s2, then 2p6, 3s2, 3p6, 4s2, 3d10, and so on. Now, orbitals. In S orbital, there is only 1, so the circular one, that's it. We don't have any more orbitals in the S subshell. So S subshell, we have 2 electrons. But for P, we have 3 orbitals. There is px orbital, py orbital, and pz orbital. As you can see, S is spherical shaped, but P is dumbbell shaped. You have to memorize the shapes as well. So in each of the orbital, we have 2 electrons. In px, there are 2, py, there are 2, and pz, there are 2, which means all p orbitals can hold of a total 6 electrons. Total 6, but if we separate them by orbital, it's 2. D has 5, so in each we have 2 electrons, so they hold 10. F has 7 orbitals, and in each we have 2, so maximum. In F we can hold 14 electrons. I hope it's clear. We'll move on. Distribution. Electrons have opposite spins to counteract the repulsion due to alike charges. As you can see in the example, we have 1s. One electron is going up, the other is going down. We can't have them moving in the same direction because they both have negative charges and they will repel. So opposite spins. When there are more than 1 orbital of a single sublevel, electron pairing does not take place until all orbitals are already occupied with at least 1 electron. So as you can see in the example of 3p, p has 3 orbitals and we have 3 electrons. So we'll have to first put each electron in each orbital, and once all of them are occupied, then we'll start pairing up. As you can see in the right way, there is 1 electron in each orbital. So the correct way is to fill each orbital first and then we start pairing. To shorten electronic configuration, use the symbol of the nearest noble gas in brackets followed by the remaining configuration. Since if we write the electronic configuration complete, it can be really long, we can shorten it by first writing the closest noble gas to it, which in case of aluminum is neon. The amount of electrons in neon, we are now going to leave it and continue with the other electrons. Now we're left with 3 electrons, so we'll write 3s2 and 3p1. When adding electrons, you fill lower energy subshells first and then you move on to higher energy. And when removing electrons, you remove from higher energy first and then lower energy. But if the configuration ends with 3d subshell, then you first remove from the 4s subshell before you remove from 3d. That is because a fully filled 4s subshell is higher in energy than 3d. Because 4s and 3d are really close in terms of energy. A filled 4s is greater in energy than 3d. Let's see, we have example. Magnesium, the ground state is 1s2, 2s2, 2p6, 3s2. If we have to remove 2 electrons, we'll remove from 3s. So 1s2, 2s2, 2p6, that's it. But for iron, we have the ground state is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. As you can see, it's ending in 3d, and if we have to remove 2 electrons, we're going to remove from 4s2, not 3d6. So the new configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. There are some exceptions. So, stability. Most stable forms of a sublevel is either half-filled or completely filled. So in chromium, in case of chromium, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. It's not 4s2, 3d4. We're supposed to fill the lower energy level first. But as it said that half-filled are more stable or completely filled are more stable. If we had written 4s2 and 3d4, 4s would be completely filled, but 3d4 is not. So to maximize stability, we will fill 4s1 halfway and 3d5 halfway. If you remember, d subshell has 5 orbitals, so 1 electron in each orbital, so it's half filled, as well as 4s. Copper, that is also an exception. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d10. It's not 4s2 and 3d9. Copper promotes 1 electron from the 4s orbital to the 3d orbital to achieve a fully filled 3d subshell and a half-filled 4s subshell, which is more stable. Okay, so lastly, we have this periodic table. Just remember that this is the S block. This is S block. The elements in this section will always end with S. Like when you write out their electronic configuration, it will finish with S. This is the D block. When you write this section's electronic configuration, it will end in D. When you write this section's electronic configuration, it will end in P. So this is a P block. And lanthanides and actinides, this is the F block, and when you write their electronic configuration, it will end in F. So let's look at some questions. Bromine exists as 2 stable isotopes. The 2 isotopes are represented by the symbol Br7935 and Br8135. Give one similarity and one difference between these 2 isotopes by referring to the number of particles in the nuclei of the 2 isotopes. So we have to talk about number of particles in the nuclei. So in the nuclei we have protons and neutrons. Similarity is, remember, isotopes are elements with same number of protons but different number of neutrons. So similarity is number of protons. You can ignore same number of electrons because in the question it says number of particles in the nuclei. So same number of protons the difference is going to be different number of neutrons. Or you can just write out the number, like you can calculate it: 79 minus 35 and 81 minus 35. A sample of potassium is known to consist of two isotopes with mass number 39 and 41. For each isotope, complete the table below to show the number of protons, neutrons, and electrons. So we are given the mass number, which is 39 and 41. To see the number of protons, we have to look at the periodic table, and in the periodic table we have 19. Number of protons is 19. To calculate the number of neutrons, we have to subtract 19 from 39 and 41. Number of electrons is the same as number of protons. So 39 minus 19 gives us 20, and 41 minus 19 is 22. And again, electrons remain the same. The relative abundance of the two isotopes in a sample cannot be found in a chemical test. Give the reason why, despite the difference in atomic structure, the isotopes have the same chemical reactions. If you remember, atoms react by either giving or taking electrons, and since in isotopes electrons are the same, there is no changes in number of electrons, the chemical reactivity remains same. That's why you can't see if there are two different isotopes in a chemical reaction. Isotopes' chemical reactivity doesn't change due to no change in number of electrons, as atoms react by either giving or taking electrons. Which of the following pairs of ions are isoelectronic? Isoelectronic particles that have same number of electrons. We have nitrogen, which has gained 3 electrons. If you remember, electrons, if you gain, you get a negative charge, and this nitrogen has 3 negative, which means it has gained 3 extra electrons. Original nitrogen has 7 electrons. 7 plus 3 is 10 electrons. And chlorine has 17, and it has gained a single one, so it will be 18. So it's not isoelectronic. And oxygen has original 8, and it has gained 2, which means 10. Sulfur has 16, has gained 2, which means it has 18. 18 and 10, not same. Sodium has 11, and it has lost 1, so it's 10. Potassium has 19, and it has lost 1, so 18, not same again. Sodium has 11, lost 1, so it has 10 electrons. Magnesium has 12, and it has lost 2, which means 10 electrons. So our answer is D. Na plus and Mg2 plus both have 10 electrons, so they are isoelectronics. Complete the electronic configuration of a bromine atom using the SPD notation. So we have the symbol of argon in the beginning. If you remember, for shorthand electronic configuration, we write the closest noble gas, and in bromine's case we have argon. Argon has 18 electrons and bromine has 35. So 35 minus 18, we'll continue on with the remaining electrons. Bromine exists as 2 isotopes with mass number 79 and 81. Complete the table to show the number of subatomic particles in a 79 bromine atom and an 81 bromine ion. So for the electronic configuration, we have, after argon, we have 3d10, 4s2 and 4p5. And for protons, number of protons remain the same, 35, 35. For the neutrons, for 79 bromine, we're going to subtract 35. 79 subtracted 35, we have 44. Electrons are the same as proton number, so 35. And for 81 bromine ion, we have 35 protons. 81 minus 35 gives us 46, and this is an ion. It has a negative charge. It has gained 1 electron, so 36 electrons. So write down the electronic configuration of titanium with SPD notation. So if you look at the periodic table, titanium has 22 electrons. So we'll write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Okay, that's pretty simple. What would the new configuration be if you remove 3 electrons from titanium atom? So if you remember, if the electronic configuration ends with 3d shell, then we have to remove from 4s before we remove from 3d. So the new configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. What is the electronic configuration of nitrogen? So nitrogen has 7 electrons. All of these options have 7, but we need to make sure we have the correct one. The first one has started to fill 2p before it has completely filled 1s and 2s, which is wrong. We have to fill lower energy first, then we move on to higher energy. Same as option B. 1s is completely filled, but 2s is not filled and we have started to fill 2p, which is wrong. For option C, 1s is filled, 2s is filled, but 2p we have 3 electrons and the third orbital is not occupied but the pairing has started. So this is wrong. We need to occupy all of the orbitals with at least 1 electron before we start pairing. The correct option would be D. For 1s is filled, 2s is filled, and 2p is half filled. Number of subatomic particles in an 18 oxygen atom are. So if you look at the periodic table, we have 8 protons. So already B, C, D are wrong. A is the answer, but we'll still look forward. Since there are in original atom we have 16 mass number, but over here we have 18. So 18 minus 8 gives us 10 neutrons, and proton number is the same as electrons, so 8 protons and 8 electrons. So the correct answer is A. Alright, so what are the maximum numbers of electrons in a 2p orbital and the third quantum shell? Remember, it says 2p orbital, not 2p subshell. So in each orbital we have 2 electrons, so the answer is either A or B. Third quantum shell. In the first shell we have 2, second shell we have 8 electrons, third shell we have 18. So the answer is B. Okay, in which pair do the ions have the same electronic configuration? So R plus. R plus means R loses an electron. So if this R loses an electron, it will come here. And T, 2 minus, which means T gains 2 electrons, then it will come here. R plus will be here, 2 minus would be here. So they're not same, not isoelectronic. T 2 minus, T again gains 2 electrons, so it will come here. Y 2 minus, so if it gains 2 electrons, it will come here. T will be here, Y would be here, not same, so no, not isoelectronic. U 2 plus and T 2 minus. If U loses 2 electrons, 1, 2, it will come here. And T 2 minus, which means it will come 1, 2 here. So yes, these two are isoelectronic. Our answer is C. Which species contains 15 protons, 16 neutrons, and 18 electrons? So 15 protons. So both of them are either phosphorus and sulfur. So we look at the periodic table. Phosphorus has 15 protons, sulfur has 16 protons. So automatically our answer is either A or B. 16 neutrons. For neutrons, we'll have to ignore. There's nothing about isotopes or anything. We have ions, so we have to look at the electrons. Originally, we have 15 electrons, so that means the phosphorus has gained 3 electrons. So if you gain, you get a negative charge. So the answer is A. Which row in the table shows the number of protons, neutrons, and electrons in a fluoride ion? Use the periodic table as a source of data. So for fluorine, we have 9 protons, which also makes 9 electrons, but over here we have an ion, which means it has gained an electron. So 9 protons and 10 electrons. So our answer is either B or D. So for the mass number, it's 19. So 19 minus 9 gives us 10. So the answer is D. Which of the following is isoelectronic with the chloride ion Cl-? That means chlorine has gained an electron, which means it has now 18 electrons. If we look at fluorine, F- means 10 electrons, which is not 18. Br has 35, Br- makes 36, not 18. Sodium is 11, loses an electron, which makes it 10, not 18. Argon has 18 electrons and Cl- has 18 electrons, so isoelectronics, which means D is our answer. Complete the table below. Protons, neutrons, and electrons' relative mass and relative charge. If you remember, protons have 1, neutrons have 1, and electrons have 1 by 1840. Relative charge of proton is positive 1, neutrons are neutral, so 0, and electrons have a negative 1. Which of the following species contains the same number of electrons as neutrons? So for boron we have 5 as proton number and electron number, and we have 11 as mass number. So 11 minus 5, which means 6 neutrons but 5 electrons, so it's not the same. For Na plus, which means it has lost an electron, from 11 we have 10 electrons now. 23 minus 11 is 12, so nope. Magnesium has 12 protons, therefore 12 electrons, but this is a 2 plus, which means 10 electrons. 24 minus 12 gives us 12 neutrons. 12 are not as same as 10, so no. We're left with fluorine. Fluorine has minus, so which means there are 10 electrons instead of 9. 19, so to get the number of neutrons, 19 minus 9 gives us 10. So yes, 10 neutrons and 10 electrons, which makes D our answer. An atom of silicon has mass number 29. Complete the table below showing the number of subatomic particles in this atom of silicon. Use the periodic table as a source of data. Number of protons. If you look at the periodic table, we have 14. So number of protons would be 14. To get the number of neutrons, we will have to subtract 14 from 29. And electrons would be again 14. So 29 minus 14 gives us 15. Which pair of ions is isoelectronic? We have calcium, 2 plus charge, and oxygen, 2 negative, which means calcium lost 2 electrons, which makes it 18, and oxygen gains 2 electrons, which makes it 10. Not isoelectronic. Sodium loses an electron, which is 10. Oxygen gains 2 electrons, which is again 10. So B is our answer. Complete the table to show the number of protons and neutrons in these two isotopes. Number of protons are, if they are the same element, which they are, so the number of protons would remain the same, 53, 53. For neutrons, we have to subtract 53 from 131 and 53 from 127. When iodine 131 decays, one of its neutrons emits an electron and forms a proton. Identify the new element formed by the name or symbol. So the neutron forms a proton, which means originally we had 53 protons, but now we have 54 protons. And element is defined by its number of protons. So 54 protons are owned by xenon. So the new element is xenon. And you can see the number of neutrons. Which elements are in the S block of the periodic table? If you remember, the S block was group 1 and group 2. So the answer is A, R and U. Alright, thank you. Bye bye.